All right, today we're going to dive into one of the most incredible, intricate systems in the entire human body, the female reproductive system. We're talking about a world of microscopic drama, super precise hormonal conversations, and of course, the amazing potential to create life. So how does it all actually work? I mean, how does this masterpiece of biological engineering manage everything from the monthly cycle all the way to the very first spark of a new life? Let's break it all down. Here's our game plan. We'll start with the big picture, the blueprint of the system. Then we'll take a tour of the key organs. After that, we're going to follow the egg on its monthly journey, decode the secret language of hormones, and finally, we'll witness the ultimate race to fertilization. Let's get into it. Okay, so to kick things off, let's just zoom out and look at the big picture, the fundamental design and purpose of this incredible system. So unlike the male reproductive system, all the core components here are internal, safely tucked away inside the pelvic cavity. And what's really brilliant is how it's all supported. You've got these incredibly flexible ligaments holding everything in place. Now, this isn't just for stability. No, it's a key design feature that allows the uterus to expand so much during pregnancy. It's genius, really. The job description for this system is, well, huge. It's a factory that produces egg cells. It's a hormonal command center pumping out estrogen and progesterone. It's the designated spot for fertilization to happen. And of course, it's the very first home that nurtures a new developing life. And when pregnancy doesn't happen, it also manages the whole process of menstruation. Talk about a multitasking marvel. Now that we've got the blueprint down, let's meet the key players. Each organ on this little tour has a very specific and absolutely vital role to play. Our first stop is the ovaries. Now, these are only about the size of a shelled almond, but don't let their small size fool you for a second. These are the absolute powerhouses of the system. They are the control centers that run the entire show. So, what are their two main jobs? First up is oogenesis, which is the scientific way of saying the super specialized process of producing eggs. The second big job is hormone production. The ovaries are in constant communication with the brain, secreting estrogen and progesterone in this perfect rhythm that directs the entire reproductive process. From the ovaries, our journey takes us to the fallopian tubes. Think of these delicate pathways as a direct route connecting the ovaries to the uterus. But they're not just simple tubes, not at all. This is kind of the VIP lounge, the most common place where fertilization, that first meeting of egg and sperm, actually happens. If we look closer, you can see just how elegantly they're designed. At the end, right near the ovary, you've got these finger-like things called fimbria. Their job is to gently sweep the newly released egg into the tube. Then, you've got these tiny, waving hairs called cilia that create a gentle current, guiding the egg through that middle section and safely on its way towards the uterus. The fallopian tubes lead us right to our next stop, the uterus. It's often described as being pear-shaped, but what's really amazing is that it's one of the most dynamic and powerful muscles in the body. When not pregnant, it's only about 3 inches long, but it has this incredible, almost unbelievable ability to expand to house a full-term fetus. Its wall is made up of 3 very distinct layers, and each one has a job. On the outside, you have the perimetrium, which is like a thin, protective coat. In the middle, there's the myometrium. That's the thick, powerful muscle that's responsible for contractions. But the most dynamic layer is the inner one, the endometrium. This is the lining that diligently rebuilds itself every single month, preparing a nutrient-rich, cozy bed just in case a fertilized egg arrives. Okay, so now that we've met all the key players, let's zoom in on the main event, that cyclical, monthly story of the egg itself. This is what's known as the ovarian cycle. So here's something pretty fascinating. This journey actually begins before birth. A female is born with all the egg cells or oocytes she will ever have. Millions of them. They just hang out patiently, and by the time puberty hits, there are about 400,000 left. Each month, one gets its chance to mature and be released. And here's a really key point. The egg only completes its final division after it's been fertilized by a sperm. This process just keeps on going until menopause, when the supply of oocytes is depleted. We can simplify this pretty complex monthly cycle into 3 main phases. First, there's the follicular phase. Multiple follicles, which are the little sacs containing the eggs, start to grow. You can think of it like a race where only one becomes the dominant one. Next up is ovulation, the main event. A big surge in hormones causes that dominant follicle to rupture and release the mature egg. And finally, you've got the luteal phase. The now empty follicle transforms into something called the corpus luteum, which becomes a temporary but totally crucial hormone factory. So, how does the body coordinate this three-act play every single month? Well, it's not random. It's all directed by a constant, precise chemical conversation happening between the brain and the ovaries. We're talking about the secret language of hormones. Let's break down this hormonal orchestra. There are four key players. It all starts in the brain when the pituitary gland releases FSH. That tells the follicles to start growing. As those follicles grow, they release estrogen, which builds up the uterine lining. Once estrogen levels get high enough, they send a signal back to the brain, which triggers a surge of a different hormone, LH. That LH surge is the direct trigger for ovulation. And finally, the corpus luteum takes over, releasing progesterone, the pro-pregnancy hormone, to keep the uterine lining thick and ready. It's just a perfect hormonal feedback loop.
And this brings us to the climax of our journey. All of this preparation, the organs, the timing, the hormonal symphony, it all leads to this one moment, the epic race that could create a new life. 300 million. That's the staggering number of sperm that typically begin this journey. But, as we're about to see, the odds are overwhelmingly stacked against them. This is seriously one of the most challenging marathons in the entire natural world. And what an obstacle course it is. First, they face the acidic environment of the vagina, which is the first huge barrier. Then, any survivors have to get through a thick wall of cervical mucus. After that, inside the uterus, the female immune system pretty much treats them like foreign invaders and destroys thousands more. So out of hundreds of millions of starters, only a few thousand even make it to the entrance of the fallopian tubes. It's just mind-boggling. And for the very few, proud survivors, there's one final transformation that's needed. It's a process called capacitation. The fluids in the female reproductive tract essentially power up the sperm, making them better swimmers and getting their heads ready to penetrate the egg's outer layers. Without this final, critical step, fertilization is literally impossible. And if one sperm makes it all the way through, fertilization happens. This single, newly fertilized cell is now called a zygote, and it immediately starts its journey back down the fallopian tube. As it travels, it's already dividing, from one cell into 2, then 4, then 8, becoming this tiny ball of cells, perfectly ready to implant in that uterine lining that's been so carefully prepared for it. So from a system of organs all working in perfect concert to a symphony of hormones and a journey against absolutely impossible odds, the whole process is just a marvel of biological precision. It really makes you wonder, this incredible harmony is just the beginning. What other secrets does this complex, amazing biological system hold?